Welcome to my YouTube channel. I hope you are fine. I hope this playlist is also going well for you. In the last lecture, I taught you about, in last two lectures, we are discussing about the measures of dispersion, which is also called as measures of spread, where we discussed about range and then percentiles, and then we calculated the interpolation for the percentiles, how to do get the exact value. Then we shared about the quartiles, then we shared about the variance and standard deviation. So in this now we will going to implement the all of these things in the Python. So to implement this thing, we'll go to the VS Code and we'll do the coding. So we will be using two modules. One is the numpy module, one is the stats module. Okay, very easy. Numpy, this thing not that difficult. So for quartiles we'll be using both the approaches, but for the rest all we'll be using the numpy approach as it is easy. For standard deviation and standard for variance we'll be using the stats module. So for quartiles and for this particular percentile we'll be going to use this numpy approach. So how to code it? So first you have to install the two modules. Pip install numpy statistics. So since it is already installed in my thing, it is showing required. So we will import it. Import statistics as stats and import numpy as np. So now you will give the data. So what data will give? We'll give the data starting from 15, 18, 21, 24, 27, 30, 33, 36, 39. This is the data that we give. So if you want to print data, you will print the data. Then first thing you have to check is you have to display the range. So what is the range? Is right, it is nothing but the maximum value of the data and minimum value of data. If you subtract it, you will get the value as range. So if you check the value as range, you will get the value as ranges. So this is how you print the value of range. The second thing you print is percentile. So to calculate the percentile, we will be going to use the numpy approach. So right, to calculate the percentile, we will be using the numpy approach. So now let's say if I want to find the percentile of 10 value. So what I'll write, I'll just write np dot percentile, and in this what I will do, I will put the value as 10. I'll write the value as data and I'll keep the value as 10, because in the data I want the 10th value. Similarly, if I want to print the 90 percentile value, I'll print np dot percentile data of 90 here. So now if you want to print what is the 10th value, 10 percentile value, I'll write P10 90 percentile value. Here we will write P90. Sorry, Q90. Here I should write P90, but I wrote Q90. So now if so this is you, it will print the 10th and 90 percentile value. So it uses the formula of exclusive approach. Like this, what I always tell, a method means two approaches are there. One is here, if you go to method here, you can change the method. By default, it will take the this approach. See, in by default it will take inclusive approach, but if you want you can change the method, and this interpolation also you can able to use it. So it is your choice if you want to use interpolation, average in this thing, different methods you can use like this. So like this you can able to use this particular thing. Now this is about the percentile. The third thing come is your quartiles. To represent the quartiles, we can use it via numpy also we can use, and via stats also we can able to use this. So first we will discuss the numpy approach. So we will write q25 means quartile 25. Here we will write np dot percentile. Here we will write data, we are specified as 25. Then we'll specify the 75 thing, that is np dot percentile data 75, and we'll also specify the 50th, that is median of data, percentile data 50, and we will print all of these values, that is 25 percentile Here we will give as Q25. We'll copy this. Here we'll copy this 50, 75. Here we'll specify 75, 75 and 50 percentile. This is the numpy approach. Now you have to specify the stats value. So for stats value, what you will be using? You will be using the stats dot quantiles function. Here you will specify, just you will here in this quantile you will just pass your data. So when you pass your data, what it will do, it will give you the, if I go to the official website of data, if you pass this data, it will give you the value as three, it will give you three values as output. It will give you three values as output. That is 20 quartile 25, quartile stats 25, comma quartile stats 50 and quartile stats 75. It will going to give you. These are the three values it will give you. So now if you want to print the quartile stats 25, quartile stats 25, we'll go at 50 for 75. 50, 75, 75, 50. So this is the approach of using the statistics. So I hope you understood these three topics in very well. So now we will be going to use the concept of variance. Variance is very simple. We will be using the this data only we will be going to use, and we will directly use the stats dot variance. Variance, and we'll just write the data. Here we will write variance, variance, and if you want you can print the value as variance, variance. Here we'll write, here we'll specify variance. Fifth one comes is your standard deviation. So for standard deviation it is also very simple, like we'll write standard deviation here stats dot htdef, and we'll just pass the data, and if you print the value as standard deviation, we'll write std. So this is how you can able to execute all of these things. Now we will execute this particular code. Python measures of, if I just press the tab, I'll get the complete. See, it will give you all of the values. Data is this thing. Max minus min means 39 minus 15, 24 you got. 10th percentile value you got it as 17.4, means in between this thing. 90 percentile value means you got 36.6. That is near here you got. 25 percentile value means 21 you got. 50 percentile value 27 you got, means this is your median point. Okay, median, so let's say if you this 27 is your median, so 24th it will, 21 it gave as the 25th point, 33 it gave as a 75 point. As I already told it, this in coding you won't get the exact value of this, you won't get the exact but since here we took the odd, so we got this particular value, so that is not a big deal. And here we will print the 75 values. Variance is this, and under root of variance is your standard deviation. So now here I will do one small trick. Here I will remove the 39 from here. I want to keep it even, and I want to check what will be the output. If I can press enter here, now you see that this 10th percentile value is 17.1, but 25 percentile is 20.25. Like here you will get the 20.25 option. So to print the exact values, you this method also uses the concept of interpolation. So using interpolation you can able to get the original values. So like this you can able to print all the values here. So I hope you understood the all the concepts behind these things. So so now you see in the numpy approach, if you see Q25, it is showing 20.25. But if you use the stats approach, so what stats approach is doing, if I keep the method as, let's say method as Here I'll keep the method as exclusive. Let's see if I keep this method as exclusive, and if I print this value here. So now if you see that by default it is taking the value as exclusive only. That's why it is giving us 18.75. That exclusive formula p by that value by 100 into n plus 1, that formula we took in the exclusive one. But if we keep the value as inclusive, let's say inclusive, if I keep the value as inclusive, and if I execute this again, this one, now you see these values are same. So now you understood that why numpy uses the inclusive formula. Now you see all the values that are present, all these values 20, 20.25, 20.25, 25.5, 25.5, 30.75, 30.75. So means from this what I can tell, this numpy uses the inclusive approach, but stats module by default uses the exclusive approach. But if you want, you can change the method using the inclusive approach. So this is why your method plays a very important role in displaying the values. So I hope you understood the variance, standard deviation, all topics you understood in detail. So in the next lecture, we will going to see the we will see the histogram, scatter plot, and outlier detection. We'll going to see, and then we're going to study about the covariance and coefficient and covariance. We're going to study. So that's it, guys. Please do like, share, and subscribe. Oh, I hope you're liking these lectures. So please do support it by giving like, share, and subscribe. So thank you, guys.